Top 10 Earth-like facts about Mars. Number 10. Grand Canyon. Water is a very peculiar substance that no one fully understands. However, it does appear to be the key to life as we know it. For many years, it was thought that Mars was little more than a cold, dust-blown desert, with temperatures as low as -143 degrees centigrade or -225 degrees Fahrenheit. From earlier telescopic studies, there were hints of water in its earlier times, dendritic networks that indicate ancient river courses, canyons like Madim Vallis, which is much larger than the Grand Canyon, and scoured land that points to massive outflows of water, possibly from bygone glaciers. However, in 2008, NASA's Mars Reconnaissance Orbiter spotted small amounts of water briefly flowing down some slopes on the red planet, though evaporating almost immediately. It only flows in summer when temperatures can reach 35 degrees centigrade or 95 degrees Fahrenheit. In much colder areas, some waters flow, probably because they contain salt, which lowers the temperature at which water freezes. Number 9. So much water. Mars, like the Earth, has ice caps at its north and south poles. And, in the central latitudes, it has belts of glaciers. These weren't spotted until recently as they're covered by a thick layer of dust. The dust is probably keeping the ice from melting and evaporating. Indeed, if all of Mars's trapped ice were melted, it would cover the entire surface to a depth of 11 meters or 36 feet. The reason why any loose water evaporates so readily is that the planet's atmosphere is thin. Low atmospheric pressure reduces the temperature at which water boils. This is because the water molecules need less energy to escape, and so they do. And in Mars's case, which has an atmospheric pressure less than 1% of ours, the evaporation is almost instantaneous. Number 8. The 4 seasons. Mars, like the Earth, has 4 seasons as it rotates. The main difference is the duration of the seasons. Although a Martian day is similar to ours, it's about 24 hours 40 minutes, it takes nearly twice as long to go around the Sun, 687 Earth days. In the north, spring lasts for 7 of our months, summer 6 months, autumn or fall is just over 5 months, and winter is slightly more than 4 of our months. There's a significant difference between the temperatures in the south and the north. In the Martian summer, the north's maximum temperature is -20 degrees centigrade or -4 degrees Fahrenheit, whilst in the south it can reach about 35 degrees centigrade or 95 degrees Fahrenheit. This explains the tempestuous dust storms driven by these temperature differences. Number 7. Aurora Martis. Anyone who has seen the aurora lights in the high northern or southern latitudes of our planet cannot help but be astounded by their wondrous beauty. The auroras on Earth are caused by charged particles, mostly electrons and protons, emitted by the Sun and interreacting with the Earth's magnetic field. The resulting ionization and excitation of our atmosphere emits the light that we see. Mars also has auroras. Unlike the Earth, Mars does not have a global magnetic field. It has numerous umbrella-shaped fields, mostly in the southern hemisphere, which are thought to be remnants of its now extinct global magnetism. In 2015, NASA also detected a very slight global aurora in its Mars atmosphere. Mars has an upper atmosphere of hydrogen, and it's thought that the solar wind is reacting with this. If we were on Mars, however, we wouldn't be able to see it. The light is entirely ultraviolet. Number 6. Earth days, Mars days. As we've already seen, Mars and the Earth have similar day lengths. Day lengths vary throughout the entire solar system. For example, Jupiter's day lasts about 10 hours, whereas a day on Venus lasts nearly 117 Earth days. So why did Mars and the Earth end up with similar day lengths? Nothing mysterious, just coincidence. Planets form from dust clouds that are realized during the creation of stars. Small areas of greater density, through developing a localized gravity, attract more dust to them, and so, over eons, a huge ball of compacted dust is formed, a planet. At the beginning, these protoplanets are constantly bombarded with the remaining dust and rocks surrounding them. These interfere with any spin the globe may have. Eventually, the early planet, through gravity, clears its environs of troublesome neighbors, and whatever speed it was spinning remains more or less the same. Mars and Earth will continue with their similar day lengths, unless something substantial crashes into them, and if that happens, neither we nor any bug-eyed Martians will be around to reset our clocks. Number 5. Magnets for life. Our solar system's planets fall into two categories. Moving out from the Sun, Mercury, Venus, the Earth and Mars are solid. Beyond the asteroid belt between Mars and Jupiter, we have Jupiter, Saturn, Uranus and Neptune, which are mostly made up of toxic gases with, at the very most, comparatively tiny solid or liquid cores. As far as is known, life only exists on the Earth. It's very unlikely that life could develop and evolve on the outer gas giants, simply because, with the simple chemicals flowing around, often at vast speeds, there's little opportunity for them to aggregate to form the appropriate complex molecules. Mercury and Venus are probably lifeless too. Both are way too hot. Mars, however, is an open question. Could Mars be terraformed? The big problem here is that it has no global magnetosphere to stop the Sun's charged particles, stripping it of any atmosphere and allowing water to exist as liquid on its surface. Scientists suggest that we need to place a magnetic generator between Mars and the Sun to deflect the solar wind. If this were done, atmospheric pressure on Mars could be increased and allow the ice in the polar regions to melt. This released water could then be split to release oxygen. At the moment, however, this is more science fiction than science fact. Number 4. Mount Everest Plus. We're all aware of the variety and sometimes astonishing beauty of the Earth's natural landscape, the mountains, the valleys, the canyons, and so much more. Mars also has areas of stunning landscape. One such example is the volcanic mountain Olympus Mons, which is about 3 times the height of Mount Everest. It lies in the vast upland region known as Tharsis. Tharsis is also home to astonishing lava falls, like waterfalls but of molten rock. They pour from a 20-mile diameter crater in breathtaking, beautiful flows. Number 3. Proof of life. One of the great drivers for exploring Mars is the possibility that it either has life there or did so in the past. Discovery of life on another planet would be a paradigm shift in our understanding of the universe. One of the Martian rovers has found organic molecules in the rocks of Gale Crater. Here, there was a lake some 3.5 billion years ago. As life appears to have started on Earth nearly 4 billion years ago, this is a hopeful sign. All known living things contain 4 organic molecules: carbohydrates, lipids or fats, proteins, and nucleic acids. Although these have been found in Gale Crater, it doesn't prove the existence of life there, now, or in the past. Some chemical reactions that have nothing to do with life can also produce these molecules. However, something else has been found on Mars that could add to this suspicion. It's methane gas. Many living organisms release methane, cows, termites, and rice being examples, plus the breakdown of organic material. Methane breaks down within a few hundred years. Something is replenishing it on Mars. Again, this is not definitive proof of living things on Mars. Methane release can occur in areas of volcanic action, and here on the Earth, also chemical changes in the mantle, the layer between the core and the crust. Number 2. Potatoes on Mars? The mastery of farming was critical to the development of human civilizations. It marked the transition from loose hunter-gatherer societies to complex ones that led to employment, specialization, and the development of technology. The ability to farm on Mars is also critical. Food, natural food needs to be generated there if any colonization can be achieved in years to come. Can it be done? NASA, in partnership with the International Potato Center in Peru, tried growing potatoes in Mars-like conditions. They grew the plants in sealed containers that replicated Mars' harsh climate. The soil from the Pampas de la Joya Desert had been sterilized, as microbes assist in plant growth and would thus interfere with the experiment. The experiment, such as it was, succeeded, but the results are inconclusive. First, it's possible that not all microbes were killed. Second, seeds failed to develop and cuttings had to be used instead. Radiation would almost certainly kill cuttings if they were transported to the red planet. More hopeful results were achieved at Villanova University in Pennsylvania, United States. There, some students grew lettuce, hops, kale, and garlic. They processed volcanic basalts to replicate Mars's soil. Unfortunately, basalts contain perchlorate, which is deadly poisonous to humans. It can be removed using certain bacteria, and this process could be used on Mars. Doing this would have the added bonus that the bacteria release oxygen, which would be good news for terraforming Mars's atmosphere. As Mars only receives half our sunlight, which obviously is critical for plant growth, this is also a problem, as is the dangerous ultraviolet radiation that beats down on Mars's surface. But the indications are encouraging. Number 1. The islands of Mars. Admittedly, there's no significant loose water on Mars now, but are there islands there? Ones that, like some of ours, rose from the seas. NASA is watching the island of Hunga Tonga, Hunga Hepe very carefully. It rose out of the South Pacific Ocean off the coast of Tonga in 2009, following an underwater volcanic eruption. It was expected to submerge shortly afterwards, as other such volcanic islands have done. But no, it's still there. Scientists have worked out why. Salt water from the ocean has chemically reacted with the volcanic dust and has thus stabilized its foundation. They think that that is how some of the similar-looking landforms developed on Mars during the time when it too had oceans and seas.